Hello everyone, in this video you are going to learn about two states of matter which are liquid and solid, some example of each state of matter and the characteristic properties of two states of matter. So hopefully this video will be beneficial for you. Okay, now let's just start with liquid state of matter. Liquid are more dense than gases, which are not compressible and it possesses less kinetic energy than gases. Liquid consists of boiling point itself. So what does it mean about boiling point? Boiling point means the temperature at which the vapor pressure of the liquid equals the external atmospheric pressure. And the vapor pressure is inversely proportional to the boiling point. So this related when the vapor pressure rises, the boiling point will directly fall. For example, at the normal state of the room temperature, the vapor pressure of the water is only 20 mm mercury, but when the water is boiling to 100 degrees Celsius, the vapor pressure will directly increase to 760 mm mercury. So this proves that vapor pressure increases upon heating. And after that, the water will pass spontaneously into the vapor phase. Okay, as we can see in this diagram, the process is begin when the water is boiled in the hot water, the bubbles will automatically form. These bubbles that contain water in gas state will escape to the air, and therefore it will cause the water inside the beaker become decrease.
I will continue with solid and crystalline state. First, solids are characterized as having a fixed shape and being nearly incompressible. Incompressible means that it is very difficult to change a solid's density, which is defined as density equals to mass per unit volume. They are also having strong intermolecular forces, therefore very little kinetical energy. Solids are characterized by shape, particles, and melting point. Next, what is crystalline solid? The molecules or atoms are arranged in repetitious three-dimensional lattice units that for a gram of crystal include a large number of units. Crystalline material has definite melting point. The melting point is reported as a single degree or a range of only 1 or 2 degrees. Crystals may be units of atoms, molecules, or ions. There are two types of solid crystal. One is isotropic and another one is ionoisotropic. First, isotropic, having distinguishable light properties in all directions, and they are amorphous solid and crystals, but only those crystals of the cubic system. Ionoisotropic are crystals other than the cubic. These crystals have unlike light properties in different directions. Light is refracted by this crystal at different angles from different sides. Next, types of crystalline structure. First, as you see, simple cubic. Second, face-centered cubic. Third, body-centered cubic. The next, simple tetragonal, body-centered tetragonal, hexagonal. Simple orthorhombic, body-centered orthorhombic, face-centered orthorhombic. The last, we have rhombohedral, face-centered monoclinic, simple monoclinic, and triclinic.
What is crystal habit? Crystal habit is the external appearance of a crystal. Quantitative description of a crystal means knowing the relative surface area, length of the third axis, the angle between the surface, and the shape factor of the crystal. Shape factor is a mathematical way to illustrate the geometry of a crystal. The first one is volume shape factor, where the volume is equal to alpha length cubic. While another type of factor is area shape factor, where the area is equals to beta length cubic. Now, I would like to explain on the factors that influence the crystal habit. There are only two factors, that is internal structure and crystal growth condition. Growth rate, solvent use, and presence of impurities are examples of crystal growth condition. Now, I would like to talk about the influence of growth rate on crystal habit. In the diagram below, we can see An example of two forms of sodium chloride crystal. Actually, various forms of sodium chloride crystal are formed in different growth conditions. Okay, as we can see here, diagram A is the form of sodium chloride crystal due to the fast growth condition, while diagram B shows an example of sodium chloride crystal due to slow growth condition. Here are few types of crystal habit. The first one is prismatic habit, the second one is pyramidal habit, and the third one is tabular habit.
Common crystal habits and formation condition. The horizontal axis represents the temperature. The vertical axis represents the supersaturation, namely the amount of water vapor in grams per cubic meter, in excess of that required for saturation. In this figure, water saturation is defined in terms of density, not pressure, which has the effect of shifting the peak of the water saturation curve to a slightly lower temperature, about -14 degrees Celsius. At low supersaturation, small, solid, plate-like crystals can form at all temperatures. Solid prisms also form nearly -7 degrees Celsius. Within this area, we can see crystal shapes remain fairly simple until supersaturation extends above the water saturation curve. Then ice needles form, and all kinds of intricately branched crystals. The largest filigree crystal, that is dendrites, form at high supersaturation and at temperature near -15 degrees Celsius. In summary, small changes in temperature and vapor supply can lead to huge changes in growth habit.
What is polymorphism? Some material may exist in more than one crystalline form that we call polymorphism. Material that have this property, we call it as polymorph. Polymorph have different physical properties, including different melting point and stabilities. A polymorphic solid may change its crystal system in two ways, which is monotrophic and anisotrophic. Monotrophic is the changing crystal system in one direction only. Anisotrophic is reversible changing and usually is associated with change in temperatures or solvent. Paracetamol crystal system. Both orthorhombic and monoclinic polymorph are simultaneously present in an aqueous solution. The circle highlights neither shaped crystal of the form 2 polymorph. Form 1 paracetamol or monoclinic, more thermodynamically stable at room temperatures, and form that commercially used, and this form not suitable for direct compression.
Thank you, Nasrul, for guiding us. Bye.
Tak, dia cakap kalau nak kirim kat dia, hantar Jumaat. Kau nak hantar sendiri sebelum asal. Dekat biology.